This section is on chords of circles. And we're going to talk about 4 different big ideas, I guess. 4 different things that you need to know about chords and circles. And they were presented pretty well in the textbook, so I'm going to just kind of use that as my guide here. The first theorem is that if you've got a circle and you know 2 chords are equal, so let me just use my fun tools here so I can draw a circle. Let's see. I can remember how to do it. Yeah, I can't remember. Nope. Jeez. I'm trying to do something fun and I can't figure things out. There they are. Shapes. That's what I want. Circle. Okay. So I have a circle with a line by it that I can't erase. So I have a circle and I draw 2 chords and I tell you that those 2 chords are equal. What it means is the measure of the arc that those 2 chords intercept, it can also be assumed to be equal. Okay, the opposite is true as well. If the arc length is equal, you know that the 2 chords are equal. Okay, so that's the first theorem that you need to know in this section. Second one comes right here, which talks about the perpendicular bisectors of chords. So if I have another circle, and I have a chord, and I have another chord that happens to bisect this chord at a 90 perpendicular bisector, okay? That chord that I just drew must be a diameter, which is the longest chord of the circle. So if you're told that it bisects this chord in 2, that longer chord has to be the diameter. That's the second theorem. Okay? The third theorem says that if this diameter bisects a chord in 2, it creates, sorry, let's start that again. If the diameter is perpendicular to any chord in the circle, the 2 pieces of that chord it creates are equal. So it is, in fact, the perpendicular bisector. Okay? And then we also know that these arcs are equal as well. Okay? And I'm going to show you a couple of examples to put this into play, but for now, did I do that one? If a diameter is perpendicular to a chord, then the diameter bisects the chord and its corresponding arc. Okay? And then number 4 is if you're in the same circle, and I have 2 chords, I don't know their length, but I'm told that the perpendicular distance from both chords to the center is equal, then I know those 2 chords must be equal. Perpendicular distance from the center is equal, then those 2 chords are equal. Okay? All right. So, looking at a couple of examples at the bottom of the textbook here. Example 1. Is the converse of the chord theorem number 2 true? The chord theorem number 2 said if I have a chord that is 90 degrees to another chord, then that chord has to be the diameter. So is it true that if it's a diameter intersecting a chord, that it must be 90 degrees? That's the converse. There's an example of when that's not true. Right? It bisects another chord, but it's definitely not at a 90. So the converse isn't true. But if it does bisect at a 90, it has to be the diameter. Okay? Number 2, using what we know now about the fact that these 2 perpendicular distances to the chords are equal, tells us that those 2 chords are equal. So all we have to do is set 6x minus 7 equal to 35 and solve. We know the chord lengths are equal. So that's another way to use one of these theorems. And then example 3, I think I'm going to do that one. BD is 12. BCD. and A is up here. So we're given this information, and we want to find the radius of the circle. Okay? Sometimes when you are given a drawing, they don't actually draw in what you're looking for. So go ahead and take the liberty of drawing in what you're looking for. So if I draw in the radius, which is this, right? Radius, I could also draw it here. I could draw it anywhere on the circle, but it makes sense to go ahead and connect it to a point, because now what do I have? A right triangle, right? We know BD is 12. What do we know if this is A, and I were to extend it all the way to the end? It's a diameter, right? And it's bisecting this chord. So I know it's going to split this chord in half. This whole length was 12. So what is this length? 6. Do I have enough now to find the radius? Yes, Pythagorean theorem at this point. That makes sense. This is why I told you you're not done with right triangles. You're going to see them a lot in circles. So you still need to remember your 45, 45, 90, your 30, 60, 90, all your sine, cosine, tangent, Pythagorean theorem stuff. Probably won't be using any law of sines or law of cosines this chapter, but you will be using all the other stuff. Okay, let's look at the textbook check real quick. Quizzes. Find line 4. The diameter is the longest chord in a circle. True. In the figure below, AE is the diameter and E is perpendicular to BC. Therefore, BD and CD are equal. Yep. Here, if EG is equal to EF, then AB must be equal to CD. True. Question 4, if we're given this information, then we know 6 and x are equal, right? X equals 6. And we know y is 75. We know both of those. If we wanted to find x, it's just 6. Right? It splits that chord in half. And question 5, in the beginning of the section, there was an example of how circles are used in architecture. Which country was it? Was it Spain? Okay. Okay, so hopefully you're finished with 6.3 from yesterday, and you can work on 6.4 today in class.